Hey there. I want to talk to you very quickly about the general idea of linking your programs. In previous videos, I've described exactly how to perform the linking stage when you're compiling a program. So you write some source code, you compile the source code into object files. Each file becomes one individual object file. And then when we're done, we take all the object files and we link them up into an executable program. So I've talked about that before in previous videos. But I just wanted to talk to you about the general idea of the linking stage in general. Like, what is the linker? What is its job? What is it actually doing? So try to keep in mind, for starters, each program uses virtual memory. It uses a virtual memory space. So obviously on your computer, you have real memory, but there's lots of layers of abstraction between the physical hardware and the program that's running. For starters, the operating system uses a paging system. The memory stick, the memory circuitry might be doing something else for error checking or just transport or whatever. So try and bear in mind that each program thinks that itself is kind of the beginning of memory. You could imagine it as each program thinks that its first memory location that it has assigned to it is memory location 0. But that wouldn't necessarily be the case on the computer. Your operating system probably would have come up with an offset. Let's say, for example, your computer decides to launch your program. It creates a process. It finds a chunk of memory that's available across, one or more pages of free memory. And let's say, for the sake of argument, that the starting offset for the quote-unquote real, forgetting the other layers of abstraction, the real memory location of your program is going to be, let's just say, like 1,000. I know that's unrealistically too low, but let's just say 1,000. And then let's say that your program then thinks that it starts at memory location 0. That means if your program wants to access memory location 100, then under the hood at the last moment, right before you actually hit the RAM stick or hit the page file system, a translation has to be performed. So if your program is trying to hit memory location 100, what actually happens is the general offset for the entire program gets added to memory location 100, and then that tells the computer or the operating system that what you're actually trying to do in your program is access memory location 1100. So keep in mind, all of this memory is virtual, and the modules themselves also need to know where to jump. When I say where to jump, what I mean is kind of, well, suppose for the sake of argument, you have a program that has some jump instructions or go-to instructions or like some conditional branching instructions, anything where execution is not just going to go to the very next statement. Execution is going to go somewhere else. Like maybe you have an if-else block. It's got to maybe jump sometimes down to the else part instead of the top if part. And then when it's done executing, it's got to jump until after the whole block. Whatever it may be, there will be lots of times in all of your programs where execution kind of has to jump around somewhere if the program is even a little bit complicated. So that could be a jump instruction, go to in a higher level language, not assembly necessarily, jump if not equal, and so forth. So if you imagine writing one module, you could also imagine that the module has its own virtual memory address space. Just imagine it for now. And maybe it starts at 0. That's not what we're going to say, but just like imagine the module only really knows about itself. And so sometimes when you're jumping, for example, if we're going to jump when something is not equal to something else, we'll jump to some label. And in order to jump to that label, the assembler needs to know, where is that label inside of your source code. So pretend just for a moment, this is not like a real assembly program, but just pretend for a moment that we have a text section here. And maybe this is like, I don't know, the main label that gets jumped into from GCC. And so then we have like a label down here outside, and we'll do stuff and then jump back to the original point. So we probably have to do a label here. Main finish. This is bad form, but I'm just doing it to show you what the jumping is doing here. So if we jump, let's compare, I don't know, 1 with 2 or something. Let's compare RAX to RDX, and we'll just move RAX the value 1 and move RDX the value 2, so they're not actually equal. And then we compare them, and then we say, all right, jump if they're not equal to this label. So definitely now we know, we are going to jump down to that label. So execution is going to go directly down to here. We'll do something. And then eventually maybe we want to jump back. So we'll say, maybe let's do it again. Let's do, let's do like a whole set of statements again. We'll say jump if it is equal, and we'll just like load those two registers. So 1 and 1, and then compare them, and then say jump if it is equal to main finish. This is not a video about conditional branching or jumping. I'm trying to make this as simple as I can, but I hope you understand the point is just basically we're jumping around within the same module, right? So it's easy for the program to understand where to jump if it's in the same module, or I guess the object file. When we're assembling it, it's easy to understand where to jump. Because if we're at line 8 here when we start to jump, and then the actual label here has its first instruction at line 17, well then the amount of instructions to move is just the difference. So it's easy to say, all right, if our virtual address is this, when we jump, and we're going to jump this much of a difference based on where the label is, then now we can just compute the new virtual address to jump, or the absolute address, or whatever you want to do on that particular run. But how does it know where to jump in another module? Because when we assemble this module as an object file, the assembler is only running one pass on just this object file. It doesn't really know the addresses in the other modules. It doesn't know their offsets of its labels. Even if it's a C++ or a C module, it doesn't really know the offsets. It doesn't know where the functions start and end. It doesn't know anything, because right now, if we assemble this one source code, it's only going to know about this one source code, right? And the same goes for the other modules. If we compile a C++ program to an object file, then maybe if we want to call a function or do a goto statement or something into one of these labels from this module, the C++ program won't really know where it is. It won't know what address it's at. It won't know the offset, right? So that's the job of the linker. The linker looks at all of these labels and all of these conditional branching statements and jump statements and everything, and it just decides, for starters, it decides where each module is going to start in memory. So maybe it'll say, I don't know, your C++ module starts up here somewhere, and then it'll say this assembly module starts right after it, and then another module right after that. And it'll just kind of decide where every module will start in the final executable that we're actually linking together. Once it decides the layout, then it knows the offset of all the different modules, and therefore it can compute the additional offset that it would take to get to all the labels. So then at that point, if we want to jump, let's say, from your C++ module, we'll make a function call inside of some assembly module like the one we're looking at, assuming it was written a little bit differently. Main finish return. I guess the way it's written down here, it's returning to main if we just kind of execute it as we're looking at it, but another module could call main finish as a function and still get a return statement that would actually work, even though it's probably bad design. But so imagine that your your C++ program wants to call a function called main finish inside of this module. The linker, having already laid out the modules and being aware of all their offsets, it knows, okay, so this assembly module, it was underneath the C++ module, so it'll just take that offset and add it to the offset of the label itself within the module, and then also add that to the virtual address, or I guess the operating system will do the virtual address. But the point is the linker coordinates all the jumps and the conditional branches where the functions start, lays out all the modules, gets all the offsets, and then starts replacing all of the conditional branches and jumps and things with the real offsets that make it actually doable. Like, let's jump to exactly this memory location in code. Exactly in quotes, because we're still using virtual addressing. That's the basic idea of the linker. It knows how to jump between modules. Once the linker disguise, okay, that's all I really wanted to say. Don't forget, if you want a label to be available to jump into or to call as a function from outside the module, you got to mark it as global. So if I actually wanted somebody to be able to call main finish as a function, I just have to mark it as global. Same thing for sum label. If I say global sum label, then now at this point, another module could call this as a function or jump into it. Probably bad form to not put a return statement at this point, which means when I'm calling it up here instead of jump not equal to, I probably have to add more complicated logic so I can use a function call that gets jumped around if it is equal. But so I'm not going to go that far right now. Kind of complicated just for this video. And then also, of course, if you intend to jump somewhere else, remember that you have to mark it as external. So let's say there's a function in your other module, your C++ module, or your C module, or your assembly module. You just have to mark it as extern in the text section, in the text segment, like some other function, somewhere else, something like that. And then once I do that, now I could actually call it, I could say, call, this. Actually, that'll never get reached because the jump equal thing is at the bottom. But I could do this. I could say call it if it was actually a function, or I could say jump if it was just a jump point, or I could say, jump not equal to the other function instead of some label, something like that. So lots of stuff you can do. And now you kind of understand the idea of linking. It's taking all the modules, stuffing them inside of the final executable, and also putting data inside of the final executable. Like if you're creating a string variable in your globals area of your assembly program, or hard coding any kind of string anywhere in your C++, then it's got to be inside of the executable. Otherwise, it wouldn't be anywhere when we ran the program. So yeah, it sticks the data in there. It sticks the segments in there. It, calculates the jumps and all that stuff. I just want to point out you could put strings in a configuration file. It happens a lot, but for the purposes of a vanilla C++ or assembly program, you probably are making strings directly in the program. Anyway, so I think that's the gist of everything that I really wanted to say about what is the general idea of the linker. Thanks for watching this video. I hope you learned a little bit and had some fun. I will see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. Sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? Just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.